All right, guys, so let's welcome to chapter 15. In our last chapter, we learned how to write bash scripts and automate tasks on a single machine. Now we're going to zoom out and take a look at the bigger picture. We're going to explore different tools and concepts that professionals use to manage and schedule and deploy all of our massive scale implementations. Now, by the end of this chapter, you should be familiar with some of the most important concepts in modern IT. We're going to start by looking how to schedule tasks. We talked a little bit about cron before, but we're going to revisit this again. We're going to use cron and the one-time task called AT. Then we're going to dive into version control with Git, which is essential for managing different code and configuration files. And then we're going to start looking at the concept of containerization with Docker, and we're going to start explaining how it's changing the way that we deploy applications, mainly in infrastructure as code, which is how the entire cloud environment normally manages through automation. So, as we think of this chapter, we're moving beyond the script. We're going to write a script, of course, which is a fundamental skill, but in a professional environment, we need tools to manage those scripts. We need to track their changes and we need to deploy them reliably. So, this chapter is going to introduce the new ecosystem for you that makes large scale automation possible, from scheduling a simple backup to deploying a complex multi server application in the cloud. Now, automation is going to be one of the most powerful things when it runs on its own, without us needing to do anything to run it. Now, Linux gives us two primary tools for scheduling. The first tool is going to be cron, and we've seen this one before. It's for tasks that need to run on a reoccurring schedule, like every hour or every day. The second is AT, which is for tasks that need only to run once at a specific time in the future. So think of this one like the just once tool. Now, just a quick refresher on cron. Remember, the cron daemon or the background service is always running. Every minute it checks configuration files that we like to call cron tabs to see if it needs to run a job. To edit a schedule, we would use cron tab-e, right? So cron tab-e lets us edit the schedule, and we can always use a cron tab-l to read the current cron tab. So here's that syntax recap that we talked about in the last chapter. Remember that each scheduled job is a single line with 6 fields. The first 5 determine the time, and remember it's minute, hour, day of the month, and then day of the week. Now the 6th field is used for the command itself. Now let's look at a new command that we haven't used before. Let's look at or AT. This is for when we want to run a command just one time, but just not right now. For example, you want to reboot a server late at night when nobody's using it, you can use the AT command. Now, we can use something like at 10:30 p.m. The system will then give us a special AT prompt, and we can type one or more commands that we want to run. When you're done, you just press Control D to save the job, and the system will confirm when it's scheduled to run. It's pretty cool. Now, once you've scheduled the job with at, you can manage it. And the command for this is going to be the Q command. So the at Q, ATQ. And think of Q as query. Queries the job queue to see the list of all pending jobs. If you change your mind and you want to cancel the job, we can use the ATRM command followed by the job number. This will remove it from the queue. So just like RM for remove, we're going to use at RM to remove the job. All right, let's switch gears just a little bit. So we talked about cron, we talked about at. What we need to do now is as we write more scripts, especially when we want to manage our configuration files, we're going to have a new problem. That new problem is, how do we keep track of all of our changes? What if a change you made breaks the system? Do you have what you need to go back to the previous version? This is where version control systems come in. And the version control system we're going to talk about, VCS, is going to be, well, it's probably going to be Git. Now, remember, a VCS is going to be a tool that tracks and manages changes of files over time. Think of it like a logbook or a near infinite undo button for an entire project. It'll take snapshots of your files every time you save a change, allowing you to recall any version later. Now, this is the industry standard for version control, and we use a tool called Git. Now, why use Git? Well, using Git is going to provide us some incredible advantages. It gives us a complete history of our project, and you can see who makes a change, what did they change, when did they change it, and it's built for collaboration. This also allows many people to work on the same set of files without overriding each other's changes, and it's really cool because it's got a feature called branching, which lets us create isolated experimental copies of our project to test a new idea without breaking the main stable version. And of course, it's going to provide us reversibility, giving us the power to easily undo changes, revert our projects back to a previous state. It's a wonderful tool to understand. So what's that basic workflow look like? The basic workflow for a Git usually follows these 4 steps. First, you're going to clone a project, which means you'll download a full copy of a central repository from a service like GitHub. Second, you're going to modify the files on your local machine. So this is where you're going to write your code, fix bugs, do all your changes. Then you're going to commit your changes, which is like taking a snapshot of what you've created as a save point in your local project, and then you're going to push them to the central repository. This is where the rest of the team will actually be able to see your push, your changes for your scripts. So let's look at a couple common commands with Git. Git clone is the way that we'll clone the repository itself. Git add tells which files you want to include in your next snapshot. Git commit is the actual creating of the snapshot itself. And this is also where you can put your message about what you changed. Remember, this is going to be a log for everyone else who's going to read what you changed. You do a git push, which sends the commits back to the central server like GitHub. And then a git pull, again, is going to be the opposite. It fetches the latest changes from the server down to your machine. So while clone is the entire repository, git pull is only going to fetch the latest changes. Now, Git is a great tool, but we need to move on to other automation, because what we need to do is have some orchestration. Orchestration is all about managing not just the files on a single machine, but entire fleets of servers. Now, the cloud resources that we use today is how we normally use orchestration, but we want to make sure we do it in a coordinated way. We do it together. So we use something called containerization. Containerization is a foundational technology of a modern orchestration. It lets us offer some extra capabilities as we build new machines. So let's start with an analogy. If a traditional virtual machine is like a prefabricated room that you can just drop onto an existing foundation, containers are lightweight, isolated environments that package an application with all of its dependencies. We're talking about every library, every configuration files into a neat single bundle. Now, they run on a shared host, a shared kernel, which makes them smaller and faster than VMs. And remember, our most popular container is going to be Docker. So I think I misspoke a little bit. So virtual machines should be like the full house with its own foundation. plumbing, electricity, everything, while the container is a single prefabricated room. So if I misspoke, my apologies. Virtual machine is everything, while containers could be an individualized room. Because remember, containers aren't going to run on a shared kernel. In other words, they're going to run on a shared operating system. All right, so let's be extra clear here. A virtual machine contains an entire guest operating system. It's heavyweight, but provides very strong isolation. A container, on the other hand, shares the kernel of the host operating system. It makes it extremely lightweight, fast to start, portable, but a container is normally can be moved anywhere in the ecosystem. So you can build a container on your laptop and it will run exactly the same way as if you moved it to a server in the cloud. Now, getting started with Docker is pretty straightforward. So for one, you want to install Docker on your operating system for one. And then once you have it installed, then we can run a couple different commands. We could do a Docker pull, which then downloads a container's image. Think of this as the container itself. It's like a template or a blueprint. So here we did a Docker pull of Ubuntu. We can then do a Docker run, which then takes that image and creates a running instance from it. This is the actual container itself. And then we could do what a Docker PS, which will show us the current list of all running containers. Now there's a whole bunch of other commands within Docker, which if you do use Docker, you'll get to learn about. Just understand that it's a pretty easy process to actually pull new images, run new images, and then see how they're running, and then also stop, run them, all this other fun stuff. Now, you've already probably seen container technology on the Linux desktop. Systems like Snap or Flatpak uses the same core concepts to develop desktop applications. They'll bundle an app with all the specific libraries it needs so it can run on virtually any Linux distribution without conflicts. This is going to help us solve a classic developer problem known as, well, it works on my machine. All right? And so sandbox applications are used everywhere. Docker is a sandbox application, it's a container. Snap is a sandbox application. Flatpak or Flatpak are sandbox applications or containers. These are all going to run individualized, and they're great. Just know that they're used for portability. So let's talk about cloud just a little bit more as we finish up for this last chapter of the book, infrastructure as code. So IAC is a paradigm shift in system administration. It's the practice of managing your entire IT infrastructure, your servers, your networks, everything by writing configuration files instead of manually setting things up. The huge benefit here is that these configuration files are just text, so they can be stored in Git or GitHub, allowing us to have version control, review, and we can test our entire infrastructure just like we do software code. There are two main categories for infrastructure as code. You have configuration management tools. These are tools like Ansible and Puppet. These are to manage software inside of our existing servers. Things like installing packages, starting services, creating user accounts. Think of it like group policy it is for Windows, but for Linux. Now, we can also use things called provisioning tools. Provisioning tools are more used for hosting companies, tools like Terraform. And this is usually used to create the infrastructure itself. They're the ones who are going to build the virtual machines, set up the networks, provision the database, and all in tools like AWS or Google Cloud or Microsoft Azure. Terraform builds the machines, while the configuration management is going to be with Ansible and Puppet. Finally, all of these concepts are going to come together in a practice that we like to call CI/CD. This stands for continuous integration and continuous deployment. Continuous integration is a practice where developers frequently merge their code changes, and every time they do, an automated system builds the software packages, runs a set of tests on them, and this is to help us to catch bugs early, including our security bugs. Now, once it passed all those tests, we'll move on to continuous deployment. If all of these tests pass, the new version of the software will automatically be deployed to users. This is the engine that allows modern tech companies to release new features rapidly and reliability, and hopefully without causing an outage. So let's take a summary here. For scheduling, we like to use cron. This is for recurring jobs. If we want to do a one-time task, we'll use the at command. Remember, you can have @q, @rm. There's a whole bunch of different at commands that we can use. When we get into software and configuration files, we're going to use git to track our changes. And then we'll use containers, like tools like Docker, to package and run our applications in a portable way. Remember, we can use things like Snap and Flatpak in the same fashion, basically using containers. Sandbox applications is another term for it. We manage our servers and cloud resources using infrastructure as code, like Ansible and Terraform. And all of this is going to be tied back, guess what, with CI/CD, continuous integration, continuous deployment, to make sure that the entire software delivery process is flawless, without bugs, and not to cause any issues with our systems. So this is going to conclude the look at the broader world of task automation when it comes to Linux, okay? We've covered a lot of ground, from scheduling commands to massive cloud infrastructures. Now, these are the tools and ideas that we're going to need to use as an administrator and in DevOps. So if you have any questions, let me know. But this concludes the book. We have made it through chapter 15. So the next chapter is going to be more about, let's talk about the test itself and where to go from now. Thank you.